Good morning. Thank you for making your way through the commuter traffic, something I have not missed since I moved back up to Edinburgh. So my name is S.V Pauley. I'm Assistant Professor of Distilling at Heriot Watt University, and it's an honour to be invited to come and speak with you today. I came from the gin industry, and so I thought, why not continue on and use my professional network within the gin industry and do a gin-focused PhD. We've been at this PhD for quite some time. When you become an Assistant Professor of Distilling, they say, well, really, Matthew, you should do a PhD or something, some form of qualification, because, a PhD is a good thing to have as being an academic. So we decided the issue of the day was all to do with Juniper. The issue of the day was to do with Juniper Predominance, because that seemed to be something that every time I'd go to tastings, like we have in Summer Hall in Edinburgh, and also tastings and debates we have here with the Gin Guild, it was something that kept cropping up. So in association with the Gin Guild, obviously Heriot Watt University and the ICBD, and also the Institute of Brewing and Distilling Scottish section. So I thank all of those people for contributing to the funding of this PhD and the research. So the problem, research is all about solving problems, right? So the problem we were trying to identify is, are there any trends in the perception of compounds within the complex gin recipe? So gin is a massively complex mixture of chemicals. I know we don't like to think of that. We have a more romantic, rose-tinted vision of the complexity of gins being something artisan and created within the stills, and that's great and fine, but from a scientific and technical perspective, it's a series of different chemicals found within a solution made of alcohol and water. So what we managed to do is to take some analytical chemistry and look at those gins. So I wanted to use an interesting new technique, or not a new technique, a different technique, and explore to see if we could find any trends within the analytical chemistry found within that gin sample, and then the sensory science, or the sensory perception found of those particular gins by a taste pattern. So I had an idea to use a technique called napping. And napping is the French word for napkin. So, excuse my pronunciation, it's sort of like nappe. Anyone can tell me what the French word for napkin is? No, not at all? Some people shaking their heads? Okay, I do apologise. But anyway, what I read is the phrase napping comes from the French word for napkin. So I took 8 gins and I sent them out via the postal service to various people, various notables within the gin industry. And that's within the industry as in like producers, as well as some cocktail barmen, because they are the flavour people working with flavour. So why, if you're doing a bit of research concerning gin flavour, you would draft in people from the industry at the front line of serving it to people and working with those flavours. So each panellist was issued with an A3 piece of paper that actually was cut down because it's science, there has to be a standard size for that piece of paper, and that size of piece of paper is sort of 40 by 30 centimetres. So we cut that down to size and folded them up, and on one side we'd have aroma, and on the other side we'd have taste. And what we asked them to do is take those samples and organise them according to similarities and differences. So a very, very similar gin would be placed close together. Right? A very, very different gin would be placed very far apart. And so you could then start to see the elements of perception that you were looking for. So if they were the same, see those very different ones, they are at different sides and different halves of the napping sheet, right? So they are very, very different. That's as different as it possibly can be. And if you see the very, very similar samples, they are at the same side and the same quarter of the sheet. So they are very, very the same. But then you can go very similar, but they're on the same half, but different, so same like top versus bottom and different sides. So they're similar in one aspect, but different in others. And that gives you a more subtle and nuanced way of being able to measure the similarities and differences. And what you generate is a series of grid references. And this is what it brings to me now. With all data, with all technical data, you've got to do a certain amount of quality control, especially when it comes to sensory, because we're all different. We're all a product of our upbringing, okay? We bring with us our associations with everything that's gone before us in our lived experience, which makes the whole thing quite complicated and makes sensory science an interesting, quote-unquote, interesting thing to study because it gets complicated quite quickly. So these are our results, and I was able to find people who were if their noses were off, so they weren't picking it up in the same way as the average cloud of people. And it presented itself like a sort of lonely little dot, like one of these dots, but a lonely little dot, it fell away and go, right, okay, that person is not performing this particular round, so we'll disregard their results, and that gives us a stronger average. because you have a certain amount of quality control involved. So what we were able to do was group together. The first group were the same distillery. We've got the 2 botanical variants, so they did well. This is on taste. And then we had the same distillery but different recipes, so they were grouped together. That's nice. And then we had maximum fruitiness. So these guys were the maximum fruity gins. I deliberately chose certain gin samples from certain distilleries and certain recipes, and so that I could then work out what questions were being answered by the panel. So, and they didn't do a bad job on taste. So then we go on to aroma. Again, same distillery, 2 botanical variances. They're in the same quarter. Then we had the same distillery, different recipes. Again, same but different, okay? And then the maximum fruitiness had their own corner and their own half. So that was, I reckon, okay. But what we started to see with the numbers was that actually it didn't quite hit the statistical bits we wanted to do, hit the quality marker we wanted to hit. So what I'd like to say is, next thing we did is we asked the panelists to give us the idea around what they were picking up on that particular sample, because we're looking for granular detail. And we asked them to give sensory descriptors, and then I had to classify that because we had some very creative answers. So thank you very much to all the people who answered our questions. So yes, I categorised it into juniper, citrus, spice, earthy, right? Because that was broadly which category I would put it into. So what I then did is I mapped those out, and on smell and taste, you were pretty much agreeing with each other. This is a heat map, so it gives you an idea of the votes, the notes associated with citrus, juniper, spicy, and earthy. And that overlapped quite nicely between taste and aroma, so that's quite a good starting point. So the analytical chemical profile was then broken down into similar sensory. So don't forget, I have a machine that spits out a big one of those sort of like a wavy line, and I can say, what was the presence and absence of that chemical, what was the presence and absence of this chemical, etc., etc. And from that, I looked at the chemicals, and I went, well, that actually, if you go onto various websites and various papers, you can find the description of that chemical in isolation. So within that chemical, you can say, right, that should be smelling of citrus, or juniper, or earthy. So I looked at that, and that's the analytical data. And that analytical data, you can see there, it's kind of in sort of agreement with the sensory. So if you combine the sensory, we weren't too far removed, but there was a big gap around earthy. So we thought, actually, when we look at this as an idea, mapping technique is an interesting way to screen samples. So say we want all the juniper samples. But it's not, I wouldn't say, I don't want to take this further forward and continue on to this. I want to go for a more traditional descriptive analysis. So then, we may have noticed we've been through some stuff recently, right? In the last little while. And as with everything, there are unintended benefits, and then the phrase, an ill wind blows nobody any good. I was presented with an interesting opportunity because I am a member of the judging panel for the Scottish Gin Awards, which is run by Cara Technology. And as a member, and then as we went to remote judging, they would send out samples. So all of a sudden I had a whole load of gin samples, more gin samples than I could possibly afford to buy, in my house, and my colleague Dr. Annie Hill, and so I had even more gin samples. So I said, Annie, hold on to your samples, don't throw them away or don't drink them. So with much restraint, Associate Professor Annie Hill, held on to her gin samples and gave them to me. So I had the opportunity to look at these gin samples and analyse them. So I was able to I had 77 gins, and I did this analysis and gave me this amount of data, which is a lot of data, right, by anyone's stretch. So I used to stare at this, and I was quietly going bug-eyed, and I was scratching my head and thinking, well, how do I look at this, and how do I build relations? How do I find It's all about patterns, right? We're looking for patterns. And working at Heriot Watt University, I have access to some very, very clever people. So I put the shout out, who do I know that looks at data, large amounts of data, and plenty of it? And I found a lady called Mayren Kasadi, and she works in microfluidics, which I sort of know a little bit about because I had to Google it to find out exactly it. And someone said, go and talk to Mayren. She knows about these sort of things. She works in medical research with microfluidics. So I went and I showed her this, and I was like, what do I do with this? This is a lot of data. So she said, you need to look at machine learning. I was like, sorry? Well, so you need to look at machine learning because this is exactly what this is for. And I said, right, so, but what, how, hang on, what, huh? And she's like, right, so you're looking, and I had looked at it and thought, well, maybe that compound might be a trend. He said, no, stop. Machine learning, and you're going to be coming back into artificial intelligence later on, it asks questions, it goes, right, look, no, yes, no, yes, no, yes, no, yes. It said, ask yes, no, yes, no, yes, no, yes, for about, as many samples as you can give it. And the more samples you can give it, the better. So, having spoke to another few professors to do data handling, we came up with an idea. So it becomes, sensory studies become data handling pretty quickly because you're generating a lot of data. We all generate a lot of data. We've got one of these in our pockets. So a lot of data is being generated. And sensory analysis generates those signals, and we're looking for patterns because that's how we associate, we can extract meaning. So we're looking at machine learning, and we're comparing that, which is machine learning. We couldn't afford to do it 2 years ago, okay? The technology has come on apace, the computer power has come on apace. We can now do machine learning that we couldn't even imagine to do when I started the PhD. So the fact that it's a part-time PhD actually played to our favour. Right, and then we're going to compare the results from the machine learning with the statistical analysis, which is what you'd have done sort of 30 years ago. So when you take the statistical analysis, regression analysis, so we take those two, we look at the same data and use the two different techniques and find out what can we learn about the two different techniques and what can those two different techniques teach us about the flavour perception of juniper or gin. So we went on. So the regression analysis is mainly used to test ideas, measure effects, and to describe associations and to model relationships. Seems pretty relevant to the cause, right? Machine learning, defined by a man in 1959, so it's new, but it's not that new, a field of study that gives computers the ability to learn without specific programming, being specifically programmed. So it can go yes, no, yes, no, yes, no, yes, yes, no, yes, yes, 100 million times, and it does it fairly quickly. You don't have enough time to make a cup of tea before it's finished spitting out the results. I'm an Englishman, that's how I measure time. So, right, applications of machine learning you will have come across. The spam filter on emails. You don't often get that much spam these days, do you? I remember back in the day when the AOL account, it was always about the spam. It was mainly the only emails I got sometimes. Detecting tumours in brain scans, it's all patterns. We're looking for patterns. What is a brain scan if not a series of patterns? Voice recognition for apps, right? So the voice is recorded, it becomes a pattern, the machine learning is able to pick up the pattern and extract meaning. Detecting credit card fraud, we are generating patterns every time you go and buy something in a shop, you're generating data, the credit card company knows that, the minute you go and do something weird and exotic like spend £5,000 on a Dell computer, thank you very much man, you cloned my credit card. They pick it up and then they say, no, is this you Matthew? And you say no. Then summarising long documents, which is a worrying thing as an academic, if we can find a machine that can summarise a long document. So that's the applications of machine learning. So I'm going the wrong way. Right, by comparing the two techniques, we can learn the advantages and limitations of those new techniques, and we can start to look at complex problems. We aim to predict the unseen sensory scores by looking at the analytical profiles. By taking that machine and the wiggly line it spits out, the profile, can we predict the sensory profile of that gin by looking at the analytical profile? I took 35 of my samples for training data, and you need to give it some data to say, look, this is what happened, this is what went in, and this is what came out. So you need, and the more samples you have to do that training data, the better and more accurate your results will be, because then it's got a bigger model. Right? Then I took 32 samples, which I kept secret from both of the techniques. It's not sentient, I don't keep it secret. I just didn't expose it to the algorithm. I took those 32 samples, and then having trained the data on the 35, and said, right, go, predict. And they scored, we combined taste and aroma. So, this is all preliminary stuff because of the number of samples I got my hands on. 75 is a nice number, and some of the statistics guys, I had a very excited French statistics professor who was like, "Oh, this is amazing!" He spent all the weekend looking at the data, bless him, thank you very much. I got 5 compounds identified as significant. 1 negative, so if this is in your gin, the people at the Scottish Gin Awards are going to mark you down, and 4 positive. And this is very exciting because that's a nice clear signal. 1 negative and 4 positive, right? Okay. And so I found out that the guy told me these compounds, and they said, it doesn't mean much to me, he said. I said, well, give me a moment, I'll find out. and a relative accuracy of 14%, which is not too bad, okay? I know some people might be raising an eyebrow at that. So, the spicy characteristics of a positive compound, this is according to the statistical analysis. It's a spicy, I'm not going to tell you the compounds until I publish the paper, okay? I publish the paper and I'll tell you all the things, and you can dig it apart and make it backwards and sideways and spin it upside down. But I'm not going to tell you the compounds until eventually I publish the paper. So, the sensory characteristics of a positive gin, a good scoring gin, according to statistics, this is the old school method, spicy, peppery, woody earth, musty, sweet, citrus, terpenic, which is good at low concentrations, cloves, rose geranium, pine, herbal, cedar, and camphoric. Does that sound like a good gin to you? So you think maybe the statistical analysis is producing a fairly decent gin, with the possible exception of the camphoric and terpenic, but at low concentration. I'm saying low concentrations, people, come on. So, if you put strawberry in your gin, the Scottish Gin Awards, which, by the way, includes people from London, okay, just in case you're wondering if we're all a bunch of salty Scots, and I'm from Hertfordshire, all right? I stand there, yeah. So the sensory characteristic of the negative basically tastes like strawberry, people get upset. So that means they're all on point with the whole predominance of Juniper story, so that's quite good. Okay, machine learning. What did the machine learning algorithm, having exposed to exactly the same data for training, I feel like a Rocky kind of montage moment. It's like, go machine algorithm, do your thing. After training with a set of data, the algorithm was able to predict overall scores with an accuracy of 10%. So that's better, right? Better than 14%, it's moving in the right direction. Like I say, with more samples and more analysis, we could probably hope to improve that. So, there were 8 compounds identified as significant characteristics of predicting scores. According to machine learning, the high-scoring gin would taste spicy, peppery, woody, pine, herbal, sweet balsamic resinous, which sounds quite tasty, anise, grape, I don't like anise in the gin, but that's my personal preference, fruity, herbaceous, peach, sweet vanilla, wine-like, herbal, waxy, slightly waxy, citrus, floral, and rose. So that's according to machine learning. It didn't give us any negatives, okay? So I'm afraid that it didn't pick out the strawberry one on that one. So what next? This is a shout out to children of the 80s. Just like Johnny 5, we need more input, okay? He was basically trying to program his algorithm, bless him, and he needed more data, don't we all? So I've been talking to the Scottish Gin Awards, and they've agreed to let me have all of their gin samples. That's going to be 300 samples. And then also the Gin Cooperative are moving into the space of awards. And let's be honest, the whole value in this is, yes, we're talking about the predominance of Juniper, and yes, we're talking about the flavour, and that is, there's also another issue. There's another issue that this information, this data is valid for. So I'm not the only one to have heard back chat and rumours about various awards, right? There are people saying, oh, if you pay this amount, you'll get that result. So there is a fundamental issue with certain awards, and I'm not naming names because that's obviously a bad idea, but within the awards category, there is back chat and rumour around the potential sort of validity of the awards being given. So this could be another alternative use for that, as well as looking at the predominance of Juniper. And I have to say, the people I've worked with so far have all been completely transparent and above board, and fair play to them. So yes, I will be, having been presented with, we reckon, a minimum of 360 samples, possibly going up to sort of way more than that, possibly even double that. I'm going to be applying for more funding, unsurprisingly, because all of this lovely analytical chemistry I do is lovely, but it's an expensive piece to keep. And so yes, they charge me a reasonable, but with so many samples, it soon racks up. And we'll be building on this as a proof of concept. So if we collect scores from more samples, we can increase the accuracy of the predictions. More detailed data around the sensory perception of those core characteristics. So I'll be presenting the panelists with juniper, citrus, earthy, spicy, and saying, well, can you please tell me that? The word herbal is illegal, okay? It's against the law. Anyone who describes anything as herbal gets a judo chop to somewhere sensitive because it's not okay. What does it mean? It's like, I can't, there's nothing, herbal? What is herbal? But anyway, right, so thank you very much for your attention, and cheers.